Hi, I'm Conrad Fischer. I'm the Director of Educational Development at Nassau University Medical Center in Long Island. And here is our next section. The good news is, after you've just been tortured with electrical action potential, you can now relax into something that you actually know, which is actin and myosin. Ooh, the creepy, creepy crawlies, actin myosin, pulled me along and made my muscle go in. Oh, finally something we can understand. And this is finally the one piece of physiology that actually people understood, because the entire idea of inching along like that is so nice for us. It's really the medical mind can really relate to it a lot better than the number stuff. Action potential? No, please, no, not something with a number. I can't stand it. So a myofibril. See, even that's a nice name. Myofibril, muscle fiber. Myofibril, muscle fiber. Well, each of these muscles is made up of a number of fibers, and each of these fibers is called a fibril. Woo, I love it. Gotta love it. Now, why it can be subdivided into sarcomeres. Sarco means flesh or muscle. Sarcos, the word for flesh or muscle in the Latin. And it's divided by Z lines. And you might be, why are they put there and why are they called Z? Because they wanted a word that meant the end. They wanted a letter meant the end. The end. Z lines at the end. Cool, thank you, pleased, tickled. So, each muscle is made up of fibers, and each fiber is made up of fibrils. And each individual fibril is divided up into units called sarcomeres. Little units next to each other, sarcomere. And each sarcomere is broken up into thick and thin filaments, which we like to call actin and myosin. Thick and thin, actin and myosin, which pull them across. Now, the points of attachment have different names to the bands. A band, I band, H band. Well, the moral is it just showing actin? Is it just showing myosin? Is it showing the combination? And it probably would be better to have words that actually meant the actin band, the myosin band, and the combo band. It'd be better to be at McDonald's. I have a number 7 in actin myosin combo band. Thank you. So these Z lines is simply the end of the sarcomeres. Each sarcomere is one unit. And in each unit with a Z band, because we wanted a letter that would symbolize the end, we have zones that, let's see, the I zone or band is just the actin. And the H zone is just the myosin here in the middle. And then we have an A band, which is sort of the combo. Now, you're going to like this because once you see it, you see simply that there are these different Z lines, and based on the interaction between actin and myosin, look up, they pull each other along and go, E, 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 E. You like that. Crunchy, 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 crunchy. Very easy. You're going to like that. So it's one of the most identifiable and easy to understand things. Each muscle is made up of myofibril. Each myofibril is made up of multiple sarcomeres joined together as Z lines, Z bands, and the actin and myosin filaments joined together in a juncture pull each other towards each other. Well, what we know. The main thing is we have a nerve, and the nerve is going to terminate on this thing, and the nerve is going to terminate and send a propagation impulse down that nerve, and when that impulse is going to go down that nerve, what happens is it stimulates acetylcholine to go across that neuromuscular junction, and when the acetylcholine goes down the neuromuscular junction, it's going to save a wave of depolarization through that myofibril, which is going to release calcium. And when it releases calcium, the calcium is going to descend through the T-tubule, and the T-tubule is such a great idea. It's such a nice name. It's just a subway system for calcium. The sarcolemma is the overall covering of the muscle cell, the myofibril. The sarcolemma is the ultimate covering of the myofibril. You're going to have sarcoplasmic reticulum, and the sarcoplasmic reticulum is what's going to dump calcium through the T-tubules. So neuromuscular transmission sends a wave of depolarization of acetylcholine down through the sarcolemma and into the muscle cells. What's going to happen is the sarcoplasmic reticulum is going to dump a bunch of calcium through the T-tubules, and the T-tubules will take it into the muscles. Zip! T-tubules. On the outside is the sarcoplasmic reticulum. It gets an impulse, and the T-tubules go through the muscle and dump calcium. And when the calcium touches everything, it contracts. It's a very simple 1, 2, 3, 4 process. Medical students love it. Residents love it because it's one of the easiest things, and frankly, it's one of the only things you came into medical school really understanding. The sarcoplasmic reticulum sends calcium through the T-tubular system. The T-tubule system is like the transit system. It's the subway system going through the muscles to rapidly disseminate calcium so that the muscles can contract. It's fantastic. Ooh, thick and thin. Why can't we say the actin, please? Actin and myosin, please. Actin and myosin. Well, we have actin here, which is the thin filament. And the thin filament, well, you're going to love this because it's a very nice system. And the system is that myosin is longing to attach to the binding site on the actin. So this head of myosin is longing for the binding site on the actin. But the binding site for the actin is covered over and hidden by tropomyosin. Tropomyosin covers the binding site, so the myosin head can't find it. Tropomyosin has to be moved so the calcium can bind and the myosin can bind. You don't like it. Ready? Tropomyosin blocks the myosin head from attaching. We need to get the tropomyosin out of the way. Calcium grabs the troponin and pulls the tropomyosin out of the way. When the tropomyosin gets pulled out of the way, the myosin head can attach and pull the muscle. Calcium binds to the troponin. The troponin gets pulled out of the way and pulls the tropomyosin off of the binding site so myosin can bind. Again, calcium binds the troponin. The troponin pulls the tropomyosin out of the way, and the myosin head can bind and pull along the contraction. Neural impulse sends a wave of depolarization through the myofibril. The sarcoplasmic reticulum pours calcium through the T-tubules. The calcium attaches to the troponin. The troponin pulls the tropomyosin off of the spot that myosin will attach to. And it's activated. So here we have actin, that does nothing. Troponin binds the calcium. The troponin's function is to move tropomyosin. Tropomyosin's function is to block the binding site for the myosin head. Calcium attaches to the troponin. Calcium attaches to the troponin. The calcium attaches to the troponin. The troponin moves the tropomyosin. The troponin moves the tropomyosin out of the way so that the myosin head can bind. And again, let's see. The Z line, okay. What happens? Calcium comes in. Calcium moves the tropomyosin. The tropomyosin, and it's moved, allows the myosin head to bind. It moves the actual muscle, and then the myosin head will detach when you have an ATP being split. And those are our steps. So, hydrolysis of ATP is necessary for 2 steps. 1, to get the thing to move. 2, to get it to detach. 1, to get it to move. 2, to get it to detach. The tropomyosin prevents the cross-linking to actin. The calcium attaches to the troponin and moves the tropomyosin. The myosin head will cross-link and bridge to actin, where it will move and slide the myosin and actin filaments with each other. ATP has to be split in order for it to detach. Now, the electrical action potential comes down the neuron. It sends an impulse that will open the calcium channels. The sarcoplasmic reticulum will release calcium. The calcium release activates muscular contraction by sending calcium down the T-tubules onto the troponins. The troponins pull the tropomyosin away, and the myosin head contracts. Sarcoplasmic reticulum is the storage site for calcium. Sarcoplasmic reticulum is the storage site for calcium. The electrical impulse removes calcium from the sarcoplasmic reticulum and allows it to disseminate through the muscle, which then binds the troponin, moves the tropomyosin, and exposes the binding site for the myosin head. You need 2 ATP splits to get this party started. At the beginning, the myosin ATPase gets the thing moving mechanically. And then here it is, the sarcoplasmic reticulum pulls the calcium out of circulation and gives the other ATP. The sarcoplasmic reticulum will give the calcium, and then it will suck the calcium back up. The sarcoplasmic reticulum does both of those things. It gives the calcium to initiate contraction, and then it pulls the calcium back up. It gives the calcium, and then it sucks the calcium right back up. The calcium comes out and binds the troponin, all from the sarcoplasmic reticulum. The sarcoplasmic reticulum puts out calcium down the T-tubule system. Just remember that when it says active events means ATP is split. So initiating contraction and detaching the myosin head both split ATP.